Okay, let's continue. So we're still really on unit 5.6. It's a continuation. I just wanted to give a pause there. All right, let's talk about what like expressions are. Like radical expressions, in order to simplify them, have to have the same radicand, number under the radical, and the same index. If they don't, you can't combine them. They're not like expressions, okay? So it's kind of like, can I add x and y together? No, but you could add x plus x together. But you can't add x squared and x together. They're different. So the same thing we're kind of dealing with here is what are we allowed to add? So let's look at the first example and discuss if this is like expression or not. 3 and the cube root of 3. Well, the radicands are the same. The radicands are the same. They're both 3. Okay? But the indexes are not the same. The index on this first one is 2, and the index on the second one is 3. So these are not like expressions. They cannot be combined when we're adding or subtracting or multiplying. Okay? These are not like expressions. Now the next one, example I gave you, was the fourth root of 5x and the fourth root of 5. And I did this on purpose. These look very, very similar. The indices are the same. The 4 and the 4, they're the same. We have a 5 under each of the radicands. But one of them is a 5x and one of them is a 5. Therefore, these are not the same. So these are not like expressions. 5x and 5 are not the same. And you know that. You can't add 5 and 5x together. So these are not like expressions. Okay? Now let me show you the last one. The last one on this page is 2 and the fourth root of 3a and 5 times the fourth root of 3a. It doesn't matter that there's a 2 and a 5 on the outside. What you're checking are the indices and the radicands. So the 4s are the same. Good. And now we're going to check the radicands. This is 3a. This is 3a. They're exactly the same. Now, if one of them was 3a squared, that wouldn't work. But 3a and 3a are exactly the same. The index match, and therefore these are like expressions. Okay? And that's going to lead us into what we're doing next. Okay? The next part is when we add or subtract using radicals. Okay? Whoops, sorry, I didn't mean to do that. So if we're adding or subtracting, we can only combine like terms just like we always do in algebra. And so that's why we went over what like terms are. Okay, so we can only combine like terms. Okay, so let's look at number 1. We have 2 root 12 minus 3 root 27 plus 2 root 48. At first glance, okay, they're all square roots. Great. So they all have the same index. But they don't have the same radicands. But before we move on and decide that, you need to simplify and see then if they have the same radicands. So for example, 2 root 12 is really 2 times 2 times 2 times 3. Okay? The next one, 27, is really 3 times 3 times 3. And then that last one there is 48. So let's say I don't know it, which I can't think of it off the top of my head. It's late. So 2 is my prime factor. Then I have another 2. There's another prime. Then I have another 2 and a 6. And then I have a 2 and a 3. So no matter how you break down your tree, you should still get the same prime factors. In this case, it's 2 times 2 times 2 times 2 times 3. All right, now let's take out our prisoners. So in this first one, we can take out a set of 2's. We have the 2 waiting on the outside. The set of 2's escape. And then left behind is a root 3. Okay? The next one. We have a minus 3 on the outside waiting. A group of 3's, whoops, that's not what I meant to do, sorry. A group of 3's can escape. And so they get multiplied by what's waiting on the outside. And left behind is a 3. Notice what's happening now. We are having the same radicands. Guess what's going to happen on the end here? I think you can probably guess it. We have a group of 2, another group of 2. So waiting on the outside was a 2. And then we had 2 escape, a 2 escape, and lo and behold, guess what was left behind? The square root of 3. So let's see what we have here. This is going to be the 4 root 3. This is going to be negative 9 root 3. And this is going to be 8 root 3. They have the same radicands, and they have the same indices, the same index. So now we can just put together like we normally would. 4 root 3 minus 9 root 3 is going to give us negative 5 root 3. I just added the 4 minus the 9. The root 3 is just telling me what we're counting. Then we're going to add the 8 root 3. So negative 5 root 3 plus 8 root 3, the answer and final answer here is 3 root 3. The biggest things with radicals is knowing when you're done and knowing that you simplified it all the way. Okay, let's try one more of these. All right, number 2 is the square root of 3 plus the square root of 72 minus the square root of 128 plus the square root of 108. Well, guess what? They don't match right now, but they're all square roots. So my guess is probably some of these, if not all of these, will be combined once we prime factor. So the square root of 3 doesn't change. 72 is 3 times 3 times 2 times 2 times 2. 128, I have to do it, even though I did it the other day, now I can't think of it. That goes in 6, 4. Okay, so there's my first prime. And then that's 8 times 8. So that's 2 times, times 4. And that's 2 times 2. And the same thing happens over here. 2 and a 4. And a 2 times 2. And notice the reason I circle is so that I can count up what I have. I have 1, 2, 3, 4, 5, 6 2's under there. So this is 2 times 2 times 2 times 2 times 2 times 2. Or you could write 2 to the 6 if that makes it easier for you. And let's see if I can do 108 really quickly. 108 is going to be, it's 12 times 9, so that's 3 times 3 is 9, and then 12 is 3 times 2 times 2. All right, now let's do some jailbreaking. Well, the square root of 3, nothing happens, so that just stays. I don't know why I just did that. Okay, and the next one, though, we can bring out a 3 and a 2. Well, 3 times 2 is 6, and that's what ends up on the outside. 2 is left behind. Well, nothing can be combined there. Guess what's going to happen? We're going to combine something else. Well, we have 1 set, 2 sets, 3 sets. And in that case, we can just take out 3 sets of 2. Well, that's 2 times 2 times 2, so that's an 8. And that collapses then. Okay, so that can't be combined. Maybe this isn't going to simplify down very much. And then on this one, oh yeah, we'll have a little bit of simplifying. We have a 3. I feel like I'm missing something. Did I miscount on 128? Oh wait, let me check it. So if you're not sure, I'm going to get my calculator that I just remembered I have. Okay, so let's see here. It's under utilities. And it's there we go. And I said 1, 2, 3, 4, 5, there's 6 2's. 1, 2, 3, 4, 5, 6. Yeah, that's right. Okay. For some reason, when I did it earlier, I thought it was different. And then we would take out the 2's here. And so then we have 6 root 3. So the only things that can go together then, and there's an understood 1 in front of this one, we can put this and this together. So that's 7 root 3. 9 times 8, that's right. Plus 6 root 2. Minus 8. If somebody discovers that I made a mistake on this, if you would please let me know, because I feel like I did something wrong, but I can't find it. Okay. Let's go to the next thing. We're going to multiply radical expressions. By distributing. That's the first one. Or using FOIL. Now, when I say using FOIL, that could also mean box method, okay? So that could also mean the box method, so it's kind of up to you. So we're going to do 2 of these as an example. Okay, I keep doing that. Sorry, I don't have the screen frozen. Okay, so the first one is the square root of 2 times the quantity 3 root 2 plus 6x. Again, remember, we multiply the outside times the outside, inside times inside. So if we do this one, the outside of this is 1 times 3, so that's 3. On the inside, we have a 2 times 2. I'm going to leave that for a minute. Then on this one, the 6x is an outside number. It's not under radical. So that's just going to be 6x, and then we had the root 2 that we just distributed. Okay? Now in that first term there, we can orchestrate an escape. The 2's can escape. So when they come out, they get multiplied by that 3. 3 times 2. There's nothing left behind, so that's just 6. In the second term, nothing can escape, and so that's my final answer. Okay? All right, let's look at number 2. I'm going to FOIL it, but you could just as easily box it. 5 plus the square root of 6. This one I hate. This one gets more complicated in my mind. And 5 minus square root of 2. Okay? So let's FOIL. First times first. There's my f. So 5 times 5 is 25. Outside times outside. Well, 5 times negative root 2 is going to be negative 5 root 2. Okay? Then inside times inside. So we have a 5 times the root 6. So it's just going to be 5 root 6. Because remember, there's a 1 out here. So we're really multiplying that 5 by the 1 that's outside. So that's inside times inside. And then our last thing is, let me pick a new color that I haven't used. L is negative root 6 times 2. Well, I'm not going to write it like that. I'm actually going to write 2 times 3 times 2. Now I'm going to see if there's any jailbreaks that can occur here. Well, that's why I wrote this one. So we have a group of 2 that can come out. Now that leaves us with 2 root 3, but this is why I hate this problem. Nothing else can simplify. 25 is already simplified. 2, there's nothing to escape there. And then the 6 is just 2 times 3, so that can't escape. So this is our final answer for that. Okay, we're actually not done this yet. We still have to do a more difficult part. So I'm actually going to pause here and do a third video so that you can kind of take a break.